nuclei, releasing more neutrons. The generation of neutrons can produce 27 different fissions as we go on, and 81 and so on. So each of these neutrons, watch an animation of that chain reaction. Now what you see here is within a fraction of a second, the whole mass of uranium can undergo fission. Look at that. It doesn't take a very long time. So each of the neutron produce fission, further fission in other uranium-235 nucleus, releasing more neutrons, more fission, more neutrons, more fission, and it spreads right through the material within a very short time. Now, such a chain reaction is called an uncontrolled chain reaction. Well, an uncontrolled chain reaction is what we use in the construction of a bomb. But if you want to harness nuclear energy and use it for producing electricity or any other peaceful purposes, then we cannot allow this uncontrolled reaction to take place. We must control it by some means. We will talk about that briefly as we move on. Okay. Well, that brings us to the next concept of what is called critical mass. Can the chain reaction occur in any amount of uranium? Suppose I have this much of uranium. Can a chain reaction be sustained in a small mass like this? Well, that's an important factor. In order that a chain reaction may be sustained within a given mass of fissionable material, at least one neutron per fission should be available to produce further fission. Now, if those neutrons are allowed to escape, suppose you have a material, say like this. One nucleus absorbs a neutron and it undergoes fission, producing, let us say, 2 neutrons. Now, if those 2 neutrons, these neutrons are very fast actually when they come out of the nucleus. They're very fast, they carry very large amount of energy. That means they can escape the mass of the material pretty fast. If they escape before they can be caught by other nuclei, that means a chain reaction cannot sustain in a mass like this. So in order that a chain reaction may be sustained, at least one neutron produced in one fission should be available to produce further fission in other nuclei. Then only you can sustain it. Now, neutrons produced in fission are fast moving, and there is a good chance that they escape before being captured for further fission. If the mass of the fissionable material is too small, the neutrons have a greater chance to escape. That means a chain reaction cannot be sustained in a small mass like that. That means in order to sustain a chain reaction, you need a minimum mass. A minimum mass that is necessary to start and sustain a chain reaction is called the critical mass of that fissionable material. So each fissionable material has a critical mass, which is the minimum amount of material that will start and sustain a chain reaction. So if you have a small amount of fissionable material which is below critical mass, it is not a very harmful object. It will not explode into a bomb. So a bomb, in order to make a bomb, you need a certain amount of fissionable material above critical mass. Well, that is probably one of the technical details of constructing a bomb. The effective neutron multiplication factor K, an important factor. What is the meaning of neutron multiplication factor? Well, each fission releases an average of 2 neutrons, let us say 2 or 3, it doesn't really matter. So we will talk about the effective neutron multiplication factor K. What is that? It's the average number of neutrons from one fission that are available to cause further fission in other nuclei. The value of K determines how a nuclear chain reaction proceeds. Can a chain reaction proceed, or will a chain reaction sort of die down? Depends on the value of K. Now what happens if K is less than 1? K is less than 1 means it is subcritical. That means less than 1 neutron per fission is available for further fission. You see, in order to sustain a steady level, for each fission at least 1 neutron should go and produce further fission. Then only you will have a sustained chain reaction. If K is less than 1, that refers to subcritical mass, and a chain reaction cannot be sustained. If K equal to 1, well, that is the critical mass, K equal to 1. That means for every fission, at least 1 neutron will be available to produce next fission. That means the chain reaction can be allowed to proceed at a constant rate. And that's very useful. On the other hand, if K greater than 1, it will be supercritical mass. That means when a chain reaction starts, for each fission there will be more than 1 neutrons made available for further fission. That means the chain reaction will go and proceed in almost an uncontrollable manner, and that K greater than 1 will result in an uncontrollable chain reaction. K equal to 1 will result in a controlled chain reaction. K less than 1 will result in the chain reaction dying down, and there will be no result. And that brings us to the concept of the fission bomb. How do you construct a bomb? All right, don't go and start making bombs. Well, you cannot. If people could make bombs easily, then this world would have come to an end long time ago. Is that right? Because there are a lot of people who want to destroy a lot of others. Our civilization, I think it is the instinct of every animal. Is that right? The instinct to kill one another. Am I right? I was hoping when I was a child in the elementary school, when those days when I used to read about wars and hatred and things like that, I used to think that as time goes on, people will get more and more matured, educated, and will become better. And the world will be a better place to live, a peaceful place to live. But are we in a better place now, about 50, 55 years after I had that dream? Not really. People want to destroy each other. Selfishness is part of every human being, for that matter, in every living creature. Selfishness. So, atom bomb, if somebody can make a fission bomb, well, I don't think our civilization will last. And so, the bombs that are at the moment are in the custody of governments, and it has to be kept in a very, well, it has to be kept so that others, terrorists will not get their hands on it. It's very important. Now, I will not go into the details of producing an atom bomb, a fission bomb, but by our discussion you know that in order to produce a fission bomb, you need a supercritical mass of fissionable material. Now, if you keep a supercritical mass, suppose this is a supercritical mass of uranium-235, I will not be able to hold it. I will not be able to survive, because this will explode spontaneously in a fraction of a second. So, you cannot really make a fission bomb and carry it with you. Well, you need to assemble it just before it is going to be released. That is, the assembly of the bomb should take place after it is being released. Otherwise, you're going to be killed by it. So how are you going to do that? Uncontrolled chain reaction in a lump of uranium-235 greater than its critical mass is an atom bomb. Now, in the construction of such a bomb, two pieces of uranium-235 are both below critical mass and kept separated from each other. Well, that is the trick of making and carrying a bomb. Well, if this is a lump of uranium of subcritical mass, safe for me to hold, and this is another lump of uranium of subcritical mass. Now, if I can by somehow make these pieces into one piece, well, that again is not very simple. I need to move these in such a way and violently sort of, well, I need to create that kind of a big collision so that the two subcritical mass become a supercritical mass. So that is the bomb. Well, how is it done? Well, America was the first country which did that. And the bomb that was dropped in Hiroshima was a bomb like this. Now, what is done is we have a detonator. Well, the sound you heard is one of the uranium pieces falling down, but fortunately it is still subcritical. We have a detonator which will fire a subcritical mass of uranium into another piece of uranium-235, again subcritical. And this will be fired at a very high energy so that the two will become a single piece, and then it will be supercritical. And that's a bomb. And this process is done after the bomb has been dropped. You cannot do it before dropping it because you need to look after your own life. So the device is safe as long as the two pieces are separated. In order to make a bomb, the detonator will fire one piece into the other so that the total mass exceeds the critical mass. Then you have a bomb.